exciting. And I'm excited about number 11. So that's why I'm going to talk about it right now. Guys, number 11 says simplify the expression. And it has the square root of a fraction. All right, the square root of 35 over 144. And guys, you know that whenever we have the square root of a fraction, for us to simplify this, we rewrite it as the square root of the numerator over the square root of the denominator. Okay? If we can multiply radicals, we can also divide them. Okay? And the square root of a fraction is equal to the square root of the numerator over the square root of the denominator. Now, when I look at this one, I can see immediately that the denominator can be simplified. The square root of 144 is 12. Okay? That one's simple. Now, the square root of 35, I don't know if that can be simplified. But remember, the method that we use to simplify a radical, we don't want to know approximately what it is. I know it's something about 5.9 or something like that. But that's not what they're asking us to do. They didn't say approximate. They said simplify. Just like we would reduce a fraction by canceling out common factors. Okay? We need to simplify this radical. And what we do is we use a factor tree. And I'm going to break this down into the square root of 7 times the square root of 5. Now these are both prime. I can't break them down anymore. And since I don't have a pair, there's not a perfect square that I can pull out of the square root of 35. So I have to put it back. I have to leave it as the square root of 35 over 12. Okay? Now, just to refresh your memory, and you can always go back and look at the videos, but just to refresh your memory, Liam, we might have something like the square root of 75 to simplify. And if we wanted to simplify this, we'd break it down. We get the square root of 25 times the square root of 3. Now this one's prime, so it's done. But I can break the square root of 25 down into the square root of 5 times the square root of 5. And those are both prime. So when I write them out in their prime factorization, I get the square root of 3 times the square root of 5 times the square root of 5. And you guys will remember, anytime I have a pair of radicals, it just equals the number that's under the radical sign. Okay? So this would give us 5 root 3. So 5 root 3 is the simplified form of the square root of 75. That's what they wanted for the square root of 35, but we didn't have any perfect squares that we could pull out. Okay? So we just had to leave it the way that it was. And it's the square root of 35 over 12. So that's our answer there. Quick question, Howard?
So if the top one was 75, would you write 5 root 3 over 12?
So Albert's question was, if the top one, if the numerator was the square root of 75, would I write it as 5 times the square root of 3 over 12? Yes. And if I could reduce here, I would. But 5 and 12 don't reduce. Okay, so we just leave it as 5 root 3 over 12. All right? Okay, good job, guys. Let's look at the next example.